Alright, let's dive into the magic behind DP transmitters. A technology that's at the heart of so many industrial processes, yet often goes unnoticed by most people outside the field. Today we're going to break down how these clever devices actually measure flow in real-world applications and why they're so essential for keeping everything running smoothly. Picture this. You've got a pipe, and fluid, maybe water, oil, or even steam, is cruising through it, sometimes at incredible speeds and under high pressure. On that pipe, you install a DP transmitter, which stands for Differential Pressure Transmitter. It's a compact device, but it's packed with engineering smarts. It's got two ports, one for high pressure and one for low pressure. Here's what happens. The fluid from the pipe enters both sides of the DP transmitter, but each side is connected to a different point along the pipe. One side is connected to the upstream section, where the pressure is higher because the fluid hasn't yet passed through any restrictions or obstacles. The other side is connected to the downstream section, where the pressure drops a bit after the fluid has moved past a restriction like an orifice plate or a bend in the pipe. Now, inside the transmitter there's a super thin, flexible diaphragm. This is the heart of the operation, and it's made from materials that can withstand harsh industrial environments. When the pressure on both sides isn't equal, the diaphragm flexes ever so slightly, just enough to notice the difference. Even the tiniest pressure change can make the diaphragm move, and that's what makes these devices so sensitive and accurate. But how do we turn that tiny wiggle into something useful? Here's where a bit of clever engineering comes in. The movement of the diaphragm is almost invisible to the naked eye, but it holds a wealth of information. The diaphragm's movement is connected to a sensor. Sometimes it's a strain gauge, sometimes it's a capacitor, or even a piezoelectric element. No matter the type, the goal is the same: to turn that mechanical movement into an electrical signal that can be measured and interpreted. This electrical signal is directly proportional to the pressure difference between the two sides. The bigger the difference, the more the diaphragm moves and the stronger the signal that gets sent out. So, if the difference increases, the signal gets stronger. This allows for real-time monitoring of pressure changes, which is crucial for process control and safety. Finally, the transmitter takes that signal and outputs a standard value, usually a 4 to 20 milliamp current that goes right to your monitoring system or control room. This standardization means that no matter the brand or model, the signal can be easily interpreted by controllers, recorders, or even remote monitoring systems. Operators and engineers can then use this data to make critical decisions, adjust process parameters, or even trigger alarms if something goes out of range. But why does this matter for flow measurement? Well, this is where Bernoulli's equation comes into play. This fundamental principle of fluid dynamics links pressure, velocity, and elevation, allowing us to calculate flow rates from pressure differences. By knowing the pressure difference, and a bit about the geometry of your pipeline, say if you're using an orifice plate, venturi tube, or pitot tube, you can actually calculate the flow rate of the fluid zipping through those pipes. The DP transmitter provides the critical data needed for these calculations. This means you can monitor, control, and optimize the flow of liquids or gases in everything from chemical plants to water treatment facilities, all thanks to the humble DP transmitter. So, DP transmitters aren't just about pressure, they're a super reliable way to figure out how much fluid is moving, all by measuring that small but critical pressure drop. They're trusted for their accuracy, durability, and ability to work in tough environments. Next time you see a massive processing plant or even a water treatment facility, just know that somewhere in those miles of pipes, DP transmitters are quietly doing the math, making sure everything flows smoothly. They're the silent guardians of process control, working 24/7 behind the scenes. And that's the brilliance behind how a DP transmitter works. It's a perfect blend of physics, engineering, and practical know-how, all packed into a device that keeps our industries moving forward.